Good afternoon, everyone. This is Jason, the technical manager of SuperMap Asia and Oceania Center. Today, I'm glad to be here to share the SuperMap AI GIS technology with all of you. Please feel free to ask the questions. You can fill your questions in the Q&A box, and later we will answer all of the questions in the Q&A after the presentation. First, please allow me to take a few minutes to introduce SuperMap to you as a company. SuperMap was founded in 1997 under the support of China Academy of Science. And at the beginning, SuperMap was founded in one of the dormitory, and now we are already a big company which has more than 3,700 employees. And SuperMap is the only one GIS platform provider which got listed in the stock exchange market. And now we have we have 38 branches and offices all over the world, not only in China, but we have the top company in Japan, and we have our offices in Jakarta, Malaysia, and also other countries. And later we also have planned to get more development in Mongolia. This is a report released by a company from American, and it shows the China GIS market share in 2015. So from 2015, SuperMap is already been the first GIS provider in the GIS market. And over the world, we have a lot of partners, and we already built a lot of win-win solutions inside of this ecosystem with our partners, such as the Huawei, Microsoft, and IBM. They are all our partner. Okay, that's just the brief introduction of SuperMap as a company. And today we are going to discuss about the GIS technology. In the new version, which is 10i 2020 version of SuperMap GIS, we mainly have 5 features. We call them as BITDC. And these 5 features is the most advanced features of SuperMap, and they make SuperMap different with other GIS platform provider. So the BITDC is a big data GIS, AI GIS, 3D GIS, and the distributed GIS cross-platform GIS as a basic to support the whole system. Today, our topic is mainly about the AI GIS. So what is the core value of AI? We can say the industrial revolution is the liberated human from repetitive physical labor, but the AI liberated human from repetitive mental labor. So and this is the SuperMap AI GIS technology system. We can see from the bottom, the basic level is the data. And based on the data level, we need to have some library and then framework. And based on all of these basics, we provide 3 parts of functions. They are GeoAI, AI for GIS, and GIS for AI. So in the following content, I will show you the whole technology system from bottom to the top. The first one is data. The technical system, the first one is data. The data can be divided into different types, such as the file, the relational data, and NoSQL data. So we need to divide our data and find a suitable way to store them in the data storage, such as the SQL database or the NoSQL database. And also for the file, we can store them in the HDFS or DSF, this kind of file data storage. And for the NoSQL, we can store them in Elasticsearch, MongoDB, and others. So the basic level of AI GIS is the data. And based on the data, we need to have some library. So First, we can say there are some original library. It's used to store the raw geospatial information data. And based on the original library, after doing the data cleaning, we can get the samples. And the samples is the basic to train the model in the AI. The sample is including the sample data, sample characteristics, organization, and management. And after we got the sample, we can train the model and we can get the model. The model is including the model file and the model parameters. And after them, there is a framework. Because the AI technology is very popular this year, I think not only in China, but all over the world. So there are a lot of advanced AI framework common used in the international market. We researched all of them and choose some of them which can be used in the GIS industry. Here I listed 4 of them. The first one is Spark, MLlib, and TensorFlow, and Keras, and PyTorch. So every one of these framework has its own features, and but actually from the user side, we don't need to pay attention to the framework because they are all built in the SuperMap products, and we only need to focus on the functions. Okay, so now we are going to the functions. About the function, we divide the AI plus GIS function into 3 parts. The first one is GeoAI. That is the integration between AI technology and GIS technology. Later, I will show you the details. And the second one is AI for GIS. That means how the AI technology helps GIS to improve its function. So the last one, GIS for AI, is the same. That is how the GIS technology can help AI to improve its functions, to have a better visualization or have a better data management, or more easier to dig the value from the big data, from the big volume of data. Okay, so the following content will be the detail about these 3 parts of functions. The first one is GeoAI. So from AI to GeoAI, we already researched it for a long time. So we can split, or we can divide the functions about GeoAI, like the statistics to after it evolved the GIS technology, we can upgrade it to spatial statistics. And the machine learning can upgrade to geospatial machine learning. And the deep learning can upgrade to geospatial deep learning. First one is the spatial statistics. Spatial statistics is study and analysis the spatial data and problems based on statistical theory. Because of the spatial properties of spatial data, such as spatial autocorrelation and spatial stratification, heterogeneity, and it is necessary to analyze the overall parameters of space, spatial interpolation, spatial pattern, and spatial regression. There are some operators about spatial statistics we provided as the GeoAI, such as the geospatial distribution, characteristics, and geospatial pattern and regression, geospatial interpolation, geographic sampling, and geographical distribution. Here I will give you one example, such as this is the environmental factor identification. That is for effect to analyze the effect spatial pattern of disease. And we can get we overlay the different types of geospatial data, such as the DEM, the watershed data, and the watershed zoning, the river data, to analyze the watershed zoning dominates the spatial pattern of disease in cities. So it is very helpful from the AI technology. And the second one is spatial machine learning. Spatial machine learning is a series of methods to analyze spatial data using machine learning models. And the spatial features of the task need to be embedded into the machine learning feature calculation process. Many machine learning models are involved, such as spatial clustering, classification, and regression. There I listed of the operators of geospatial machine learning, such as the clustering, there is a hotspot analysis, spatial density clustering, and the classification is the most common use, I think, such as the map matching, logistic regression, and decision tree classification, and others. And the regression, such as the geographical simulation, the linear regression, and others. Here I will give you some example, such as this
OBS гэдэг програмыг хаачмаар ах юм. Би хаах гэсэнд нөгөө компьютероо яатсан чинь болж өгдөг.
Such as this one is the estimation of housing price impacted by the infrastructure. We choose some different variables, such as the transportation, the education, and the medical service to estimate the housing price in Beijing. And the accuracy of the result is pretty good. Also, it can be used in the crime analysis, such as based on the forest classification, the forest-based classification, we can analyze the crime rate. And based on the support vector machine classification, we can get the type of crime. And based on the hotspot analysis, we can get the crime hotspot. So that will be very helpful in the crime analysis. And there are some other operators, such as the map or road matching, that is based on the machine learning model, calculate the reasonable matching of the trajectory points to be matched and restore the real trajectory. That is based on the GPS data. They are all just trajectory points, and there will be some offset between the point and the real road, or the road in the map. So we can, based on the map matching operator, to match the points to the map road, and the accuracy can reach to 97%. And the last one of geospatial deep learning, the last one is the geospatial deep learning. It is a method to analyze spatial data based on deep learning model. Through the deep learning model, multidimensional function correlation analysis and in-depth mining of complex spatial temporal relations are carried out. At present, deep learning models such as the convolutional neural network, which is CNN, are widely used. There are some operators like the graph analysis, such as the object detection, the image classification, or the spatial temporal prediction, like the graph time and space regression, and the 3D data analysis, image analysis. They are the common used operator in the geospatial deep learning. This is one of the example. That is, inside of the SuperMap software, we can extract the safe head from a video. And also from picture, we can achieve it in the same way. We can recognize the traffic sign from multiple pictures. And another one, this is a real case we developed for our customer, that is to read the number from the meter. And also we can recognize the type of meter. And another one is another important operator is the graph time and space regression. It is a regression calculation for points, and it converts spatial temporal data into sequence signals on the graph. Let's take a look at one of the applications. We can use this operator to do the traffic prediction based on graphic neural network. This application is to predict the traffic situation in 1 hour later, and we can say the prediction accuracy can reach to 92.7%. Another application is we did for our Indonesia customer. This is to detect the palm tree from the image data, because it will be a big workload for our user to count the tree one by one manually. So based on the GeoAI object detection function, we can detect the number and the position of every tree. Even we can detect the seed tree based on the picture. And another one is object extraction. This one is pretty new and pretty useful in our GeoAI functions. That is training the neural network based on image and sample data and used for instance segmentation of image data. I will give you the example directly. So this is the one of the sample about the object extraction. We can easily get the boundary of every object from the image data. And there is a differences or the comparison between the binary classification and the object extraction. Such as this is the result from the binary classification. And we can see there are some continuous, the objects, they are all continuous with others. So they are not the independent objects like this. But if we change the method to the object extraction, every single object can be extracted independently. And we can say everyone has its own objects, has its own features. And it can be used, but the binary classification also can be used in some other cases, such as extracting the building footprint from images. The left side is the image data, and on the right side, it is the vector data, the building vector data extracted from the image data. Okay, and that's all about the GeoAI. And the second topic of my presentation is the AI for GIS. That is how the AI can enhance function of GIS. Here I listed some of them, such as the AI attribute collecting, AI measuring, AI survey and mapping, AI interaction, and AI plus AR. For example, this is a real project we did about the AI attribute collecting, such as on the left side, we can use the mobile camera to scan the damaged road and get the information of the road. Then we can easily upload the information to the network. And also we can recognize the ads, the messy materials, and the trash can. So based on the AI attribute collecting, it will be easier for the user to collect the data and upload to the server. And also the indoor and outdoor AI measuring, such as we can based on the camera to measure the distance, the area of the real object. And another one is the point cloud measuring. That is based on the point cloud inside of the AR camera. We can generate the indoor scene using our mobile camera. And another one is the AI cartography with style migration. That means the right side is our original map, and on the left side is just a style picture. We can choose anyone we like, and the AI technology can help us to extract the color table, extract the main color from the picture and from the map. Then they can be matched one by one. So this is the example. In the desktop, we can easily change the style of our map. And we can easily modify the detailed information of the map, and it will be very easier for the mapping. And another one is the smart recognition of hand gesture, such as the AI can recognize our gesture, and we can use it in the map, such as we can use our gesture to control the 3D scene, zooming, panning, and rotation. Besides of the 3D scene, also it can be done on the 2D side. All right, and another new function released by this year is the AI and AR, such as we can use the mobile camera to recognize the logo of the building and the fire facilities, the bench, the flowers, the road line, and the vehicles. So it can be used in the application of smart city or the smart park. That will be very convenient for the operation and maintainers to maintain the facilities inside of the park. After scanning the picture, we can get the detailed information of them. And AI and AR also can be helpful with the printing or with the presenting, such as when we in the supermarket, and we can use our camera to scan and to take a look at all of the products inside of this shop without going inside. And so it can be the pictures, can be the web page, or also can be videos. Okay, the last topic of my presentation is the GIS for AI. That is how the GIS can help AI technology to improve its functions. How can the AI analysis result have a better visualization? For example, this is a spatial visualization for AI. It is a traffic monitoring visualization. And we can see there are some camera points on the map. When we click the camera, we can get the real-time CCTV video on the right bottom corner. And inside of the CCTV video, based on the AI, we can monitor the number and the type of vehicles on the road. And based on the analysis results, we can create the hot spots and statistical analysis, statistical results based on the GIS platform. And this is the detail of each. And besides of detect the type of car, we can also, based on the GIS overlay analysis, spatial analysis, to draw a polygon on the video. And this road is only for the bus. So if other type of vehicles go through this way, we can detect the illegal vehicle. And also it can count the number here, such as the motor vehicle and non-motor vehicle. Another one is for the another one function in the GIS for AI is the dig vehicle tracking. That means two cars has the same number, such as if we detect the same car has, if we detect the same number has appeared at the same time, but they have a long distance, so we can see that this is a fake number in one of the car. So this is one of another application. Okay, as a summary, the AI GIS technology system is based on the framework, library, and data. And on the functions, SuperMap provides the AI GIS in three directions. They are GeoAI, which is the geospatial machine learning and deep learning function. And also we provide the processing tools from data preparation to the model building to the model application. You can use SuperMap products to achieve all of them without any coding. And the AI for GIS is we mainly talked about the AI plus AR, AI attribute collection, AI measuring, and GIS for AI, such as the spatial visualization for AI and spatial analysis for AI. All right, and this picture is showing the AI GIS product system provided by SuperMap. Suggests the framework and the objects are provided by SuperMap iObjects. And on the server side, we have SuperMap iServer, which supports the data science service and machine learning service. And iPortal supports the resource notebook. And on the terminal side, we have SuperMap iDesktop X, mainly for train the model and generate the sample, train the model, and the model application. And the results of AI GIS can be shown in different terminals, such as on the web page, on the web terminal, and on the using iClient as the SDK, and also the mobile terminal, the desktop terminal. All right, and this is the AI GIS product function matrix. I think later my colleague Chin will show you the detail about the usage of SuperMap iDesktop X, because iDesktop X can handle all of the AI GIS flow. And the last one is the hardware configuration reference. The recommended environmental reference, I listed them here. And also after the webinar, we will share the PowerPoint with all of you. Okay, so today we talked about the BITDC, and we mainly focus on the AI GIS. And thank you, everyone. I think later my colleague Chin can show you the detailed steps about how to operate and to process the AI GIS technology.